In part 1, we are asked to write sign of the complex number 1 minus I in the form x plus iy, where x and y are real numbers. Since the argument of the sine function is a complex number, we may recall from lecture 18 that the sine function, where the domain is the complex plane, may be defined as sine of x times hyperbolic cosine of y plus cosine of x times the hyperbolic sine of y. Thus, for a particular z, where the real part of z is 1 and the imaginary part is negative 1, we may express sine of 1 minus I as sine of 1 times hyperbolic cosine of negative 1 plus I times cosine of 1 times hyperbolic sine of negative 1. Here, our x will be sine of 1 times hyperbolic cosine of negative 1, and our y will be cosine of 1 times hyperbolic sine of negative 1. In part 2, we are asked to describe mathematically what happens to the half-plane, which is defined as all z in the complex plane where the real part of z is greater than or equal to 1, under the mapping from z to 1 over z. When looking at this as a function, we may rationalize this function, first by multiplying the numerator and the denominator by the conjugate of z. We may then simplify by substituting the denominator for the squared modulus of z. Further, we may consider the function as a mapping, which maps z to the conjugate of z times 1 over the modulus of z squared. To understand the effect of the mapping on the half-plane of z, we may consider this as two separate transformations. In the first transformation, we scale z by 1 over the modulus squared of z. In the second transformation, we take the conjugate of our first transformation. We may further consider the first transformation as 2, both scaling z by 1 over the modulus of z. Applying this transformation once will normalize z such that it will lie on the unit circle. Applying the same transformation a second time effectively reflects z across the unit circle, meaning that points outside the circle map to the inside of the circle, and vice versa. Points on the circle will also map to themselves. However, since our half-plane has a closed boundary at z equals 1, this is the only point where f maps z to itself. All other points on the half-plane will map to inside of the unit circle. Finally, in the last transformation, by taking the conjugate of previous transformations, we reflect z across the real axis. For this visible subset of the infinite half-plane, the first transformation maps the plane first onto the unit circle, then across the unit circle, and finally across the unit circle and across the real axis.